Hi everyone, and thanks for joining. Today I'm going to walk you through this hands-on lab available on QA platform, previously known as Cloud Academy, named Securing Your VPC Using Public and Private Subnets. I'm going to read through the description of this lab, then start the lab. In this lab, you will design a VPC with a public subnet, a private subnet, and a network address translation NAT device in the public subnet. A NAT device enables instances in the private subnet to initiate outbound traffic to the internet. This scenario is common when you have a public-facing web application while maintaining backend servers that aren't publicly accessible. A common example is a multi-tier website, with the web servers in a public subnet and the database servers in a private subnet. You can set up security and routing, allowing the web servers to communicate with the database servers. The instances in the public subnet can send outbound traffic directly to the internet, whereas the instances in the private subnet cannot. The instances in the private subnet can access the internet via the NAT gateway in the public subnet. In this lab, you will also increase the network security using a network access control list, NACL, which is an optional layer of security that acts as a firewall for controlling traffic in and out of a subnet. After completing this lab, you might consider setting up network ACLs with rules similar to your security groups in order to add additional layer of security to your VPC. Learning objectives. Upon completion of this lab, you will be able to create, configure, and test the following: Virtual Private Cloud VPC, Internet Gateway, Public and Private Subnets, Inbound, Outbound Rules, Security Groups, Inbound, Outbound Rules for multiple purposes, Network Access Control Lists, NACLs for additional security on a private subnet, Bastion host for SSH access from the internet to private instances, network access translation, NAT gateway to provide private instances access to the public internet to perform operating system updates, route tables associated with public and private subnets, intended audience, candidates for the AWS Cloud Practitioner exam, and candidates for the AWS Solutions Architect Associate exam. Prerequisites. You should be familiar with Elastic Cloud Compute EC2 basics, conceptual understanding of virtual private clouds, VPCs, subnets, network route tables, firewalls, private and public IP addresses. Some Linux shell command level understanding is helpful but not required. And let's check out screenshots for environment before and environment later. Let's see. Let's open the screenshot in a new tab to see it enlarged. Okay, and let's start the lab now. We have 2 hours and 35 minutes in this Cloud Lab instance. As usual, this first step explains that we'll be using sandboxed AWS accounts with credentials available in the left side panel. Aside from that, we have additional 11 steps and less than 11 with validation checks. So let's start with lab step 2, creating a VPC. Let's read through the description of this lab step and do that part hands-on. Amazon Virtual Private Cloud, Amazon VPC, enables you to launch AWS resources into a virtual network you have defined. This virtual network closely resembles a traditional network that you would operate in your own data center, with the benefits of using the scalable infrastructure of AWS. It is logically isolated from other virtual networks in the AWS cloud. In this lab, you will create a new VPC using the AWS Management Console. Once created, you will create other EC2 and VPC resources mimicking a common two-tiered front-end and back-end architecture in the cloud. Instructions. In the AWS Management Console search bar, enter VPC and click the VPC result under Services. Click your VPCs in the left navigation pane. The Your VPCs page lists all previously created VPCs. All new AWS accounts come with a default fully working VPC. Note, although all Cloud Academy student accounts originally have a default VPC, some accounts have the default VPC inadvertently removed. A default VPC has the default VPC column set to yes. If you don't see a default VPC in your lab environment, do not worry. You will create a new VPC and use it regardless. Click Create VPC to begin creating a new VPC. A Create VPC dialog box is opened for you. Specify the following VPC details. Resources to create, select VPC only. Name tag, enter Cloud Academy Labs. This is the name for your VPC. A tag will be created with a key of name and the value Cloud Academy Labs. CIDR block, enter 10.0.0/16. This is a CIDR block from the private non-publicly routable IP address ranges as specified in the RFC 1918. Tenancy, select default. Dedicated tenancy ensures your instances run on single-tenant hardware. For the purposes of this lab, the default is fine though. Notice the VPC and More option. Choosing this option launches a wizard that makes setting up and configuring a new VPC very simple. In this lab, you are creating the VPC manually to aid understanding of underlying Amazon VPC concepts. Scroll to the bottom of the page and click Create VPC. Amazon creates the requested VPC and the following linked services. DHCP option set enables DNS for instances that need to communicate over the VPC's internet gateway. Main route table that contains a set of rules called routes that are used to determine where network traffic is directed. Network ACL list of rules to determine whether traffic is allowed in or out of any subnet associated with the network ACL. A red warning might pop up saying failed to load rule groups. It is okay to ignore that. No subnets or internet gateways were automatically created with the VPC. You need to add them autonomously. Now you are ready to create your VPC subnets and customize the routing table. Summary. In this lab, you created a non-default VPC that will be configured with private and public subnets. Let's test out this validation check and let's proceed to do this part hands-on. So in VPC, we'll proceed to create VPC in our region as stated, here in the left side panel, and VPC only with this name. Let's copy this name tag and let's proceed to log into our cloud environment. Though we'll need our credentials to log in before VPC name. Okay. I'll switch to light mode. Let's see if we have VPCs bookmarked. Yes, we do. So at the moment we have here VPCs 1, VPC in Oregon. Let's check that out. And let's proceed to create our custom VPC. VPC only. Let's see on VPC and more. Here's an example. We'll use here VPC only. Add the name tag from the lab instruction. Cider block is 10.0.0.0/16. Tenancy default. That should be it. Let's try with that, create VPC, and let's reissue the validation check. Let's quickly scroll through the sections here. If there's time left towards the end of the lab, I'll click through each of these. Okay, great. Let's proceed to the step 3, creating a VPC Internet Gateway. An Internet Gateway is a horizontally scaled, redundant, and highly available VPC component that allows communication between instances in your VPC and the Internet. It imposes no availability risks or bandwidth constraints on your network traffic. An Internet Gateway serves two purposes. Provide a target in your VPC route tables for Internet routable traffic. Perform network address translation, NAT, for instances that have been assigned public IP addresses. Note, it does not do this for instances with private IP addresses. In this lab, you will create an Internet Gateway and associate it to a VPC. Instructions from the VPC dashboard. Click Internet Gateways in the left navigation pane. The Internet Gateways page lists all previously created gateways. Note, your student account may already have an Internet Gateway. If it does, it is likely attached to a default VPC. Regardless, this lab step will walk you through creating your own. Click Create Internet Gateway to begin creating a new gateway with the following: name tag, enter labs, GW. Click Create Internet Gateway. The state of your Internet Gateway will be detached to start. Now you need to attach the new gateway to the VPC you created earlier. Click Actions, then Attach to VPC. In the Attach to VPC form, select the Cloud Academy Labs VPC from the drop-down menu. Note, the ID of your VPC will differ slightly. An Internet Gateway can only be attached to one VPC. Therefore, even if you have another Internet Gateway and it's already attached to the default VPC, the drop-down menu when attaching your internet gateway will only include the detached VPC. Click Attach Internet Gateway. In the Details tab, you will notice the new internet gateway is attached and available to be used by EC2 instances of the attached VPC. Summary: in this lab step, you created an internet gateway and attached it to the VPC that you created earlier. Instances in the public subnet will route traffic destined for the public internet through the internet gateway. Let's proceed to create this in AWS Management Console. So from the VPC dashboard, you'll need Internet Gateways section to create a new internet gateway with this name. Attach to VPC. We created in a previous step. And rerun this failed validation check here. It checks is attached the internet gateway to the non-default VPC. In the left side panel, here we have internet gateways. As mentioned, there is one here already, but we'll create our own. As said here, you can now attach to a VPC to enable the VPC to communicate with the internet. So let's here click on Action and attach to previously created VPC. Here we are able to see what would be the command line interface command for this. ClickOps. It says Internet Gateway successfully attached. Okay, let's verify that. Great, let's proceed to step 4, creating a public subnet. Introduction. As implied by the name, a public subnet will hold resources that require ingress and/or egress to the public internet. A common use case for this is a DNS server or a load balancer sitting in front of front-end web servers or web applications. In this lab step, you will create a public subnet in your VPC. Instructions. In the VPC dashboard, click Subnets in the left navigation pane. The Subnets page lists all previously created subnets. Click Create Subnet. Configure the following subnet details: VPC ID. Select Cloud Academy Labs. Subnet name, enter public A. This is the name for your subnet. A tag with a key of name and the value public A is created. Availability zone. Select US West 2A from the drop-down menu. IPv4 subnet CIDR block, enter 10.0.20/24. Click Create Subnet. The new subnet will be deployed into the selected VPC and into the selected availability zone. Next, you will need to set up the route table. A route table contains a set of rules called routes that are used to determine where network traffic is directed. Each route in a table specifies a destination CIDR and a target. For example, traffic destined for 172.16.00/12 is targeted for the virtual private gateway. If a subnet has a route with the destination 0000/0 and internet gateway as the target, The subnet is known as a public subnet. You can create a custom route table for your VPC using the Amazon VPC console. In the left-hand navigation pane, click the Filter by VPC field and select the Cloud Academy Labs VPC from the drop-down. Note, you may need to refresh your browser tab to be able to select the Cloud Academy Labs VPC from the Filter by VPC field. In the left navigation pane, click Route Tables. Click Create Route Table. Configure the following route table settings. Name, enter Public Route Table. VPC, select the Cloud Academy Labs VPC from the drop-down menu. Scroll to the bottom of the page and click Create Route Table. On the Route Details page, switch to the Routes tab and click Edit Routes. Click Add Route. Configure the following route settings. Destination, enter 0000/0. Target, select Internet Gateway, then Labs Gateway. Click Save Changes. Up next, you will change the default route table of the public subnet to include the new route table. In the left-hand navigation pane, click Subnets. Select the Public A subnet and click the Route Table tab. Click the Edit Route Table Association button. Select Public Route Table from the Route Table ID drop-down menu and confirm the following routes. Note, the Internet Gateway under your target will differ from the ID above. Click Save. This subnet will require a route to the Internet, so the associated route table has now been configured to use Public Route Table to determine traffic rules. Summary: in this lab, you created a public subnet in your VPC and associated it with a route table with access to the public Internet. Here we have one validation. To check is there connected an internet gateway to a non-default VPC route table. So let's do this hands-on. So we'll create subnet with this name. So here in this VPC dashboard we can filter for our Cloud Academy Labs, what we have related to that VPC among subnets, so nothing yet. Now let's create subnet associated with that VPC, Cloud Academy Labs, and let's give it this name, Public A. Availability zone, we said West 2A, right? So let's check US West 2A. Let's copy paste the CIDR block. Then we will proceed to create a route table associated with the VPC. Just below subnets in the left side panel, route tables. We do not have any route tables already associated, which totally makes sense. We'll call it public route table. Associated with our recently created Cloud Academy Labs, VPC. And let's create it. Then we will, on the route details page, switch to Routes tab and click Edit Routes. So here, Routes, let's edit and add the following route. Enter 0000/0 and the target internet gateway we created. Here add route. Next, we will change the default route table of the public subnet to include the new route table. So in the subnets, public A route table, let's edit that. Select the public route table. And confirm something like the following. Different internet gateway ID and save. So now in the subnets, for our public A subnet, and here route table, let's edit route table association and add and replace with this public route table. Save. And let's reissue the validation check. Great, let's proceed to step 5, creating a Bastion host. A Bastion host is typically a host that sits inside your public subnet for the purposes of SSH and/or RDP access. You can think of it as a host for gaining secure access to resources in your VPC from the public internet. Bastion hosts are sometimes referred to as jump servers, as you jump to one, then back out of it. Once you access a Bastion host, for example by using SSH to log into it, in order to access other instances, you must either set up SSH agent forwarding or copy your SSH key material to the Bastion host. The latter is not ideal for security reasons in a production environment. If you require Windows connectivity, then setting up remote desktop gateway instead of SSH agent forwarding is recommended. This lab step assumes SSH connectivity to Linux instances. In this lab step, you will create an EC2 instance that will serve as both an observer instance that you can run various tests from and a Bastion host. Instructions. In the AWS Management Console search bar, enter EC2 and click the EC2 result under Services. To see available instances, click Instances in the left-hand menu. Click Launch Instances. In the Name and Tags section, enter Bastion under Name. In the Application and OS Images section, select the Amazon Linux option under Quick Start and select the Amazon Linux 2 AMI HVM option under Amazon Machine Image AMI. In the Instance Type section, you should not change any options. Simply make sure the default T2 micro is selected. In the Key Pair section, select the provided key pair. So that's coming essentially from here. Ends with 416. Yeah, that's it. Key pair. Note your key pair may differ from the screenshot. Reminder, the PEM or PPK formatted key pair can be downloaded directly from your lab data section of the Cloud Academy lab page at any time. In the Network Settings section, click Edit and configure the following instance details. VPC, select the Cloud Academy Labs VPC subnet, select the public A US West 2A subnet, auto-assign public IP, select Enable, firewall, select Create Security Group, security group name, enter SG Bastion, description, enter SG for Bastion host, SSH access only, type SSH, protocol TCP, port 22, source type anywhere, source 0000/0. Note, it isn't a best practice to set the source to any IP, but it is used to allow the lab to work in this network environment. If you are in an environment with a static IP, you could set the source field to My IP in the drop-down menu to only allow your IP for improved security during the deletion of this lab. Review the summary section and click Launch Instance. A confirmation page will let you know that your instance is launching. Click View All Instances at the bottom of the confirmation page. The status of your instance will transition to running within 30 seconds. Summary: in this lab step, you launched an EC2 instance with a public IP address in your public subnet that will be used as a Bastion host. In a production environment, you would restrict inbound access to specific IP addresses of your network administrators. The outbound traffic will also be modified later in this lab, restricting the destination to the security group of instances in your private subnet only. When configuring Bastion hosts, they are often stripped down to provide the minimum amount of services. So we here don't have any validation checks. Let's proceed to the hands-on part in AWS Management Console. So EC2, let's launch instance with this name and these characteristics. Let's start doing that. Here we have EC2's bookmarked. Let's launch instance. MI is this one from the list. Key pair as provided. Then we will edit network settings. VPC. public A for subnet, enable auto-assign public IP, and then let's create security group with this name, SG Bastion. So here, instead of the default VPC, let's switch to our custom created Cloud Academy Labs. Subnet is the correct one. Public A, let's switch auto-assign public IP to enable. And let's create security group with the name SG Bastion, description SG for Bastion hosts, SSH access only. SSH TCP 22 anywhere, all zeros. TCP 22 anywhere, all zeros. No description needed. And let's review and launch the instance. So here in the summary, let's preview code for our ClickOps operation. And let's launch instance. Great, let's proceed to step 6, creating a private subnet. Introduction. In this lab step, you will create a private subnet. A common use case for private subnets is to configure resources for a backend tier, such as database servers that should not be accessible from the internet. However, you may eventually want these backend database servers to access the internet for operating system updates or to be accessible by administrators via a Bastion host. Instructions. In the AWS Management Console search bar, enter VPC and click the VPC result under Services. Select Cloud Academy Labs in the Filter by VPC field. Click Subnets in the left navigation pane. The Subnets page lists previously created subnets. Click Create Subnet and specify the following details. VPC ID, select the Cloud Academy Labs VPC from the drop-down menu. Subnet name, enter Private A. Availability zone, select US West 2A. IPv4 subnet CIDR block, enter 10.0.10/24 as the CIDR block of your subnet. Click Create Subnet. The created subnet is automatically attached to the default VPC route table and the default network ACL. Note that the CIDR block differs from the public subnet created previously. The third octet differs 10.0.10/24, not 10.0.20/24. If a subnet does not have a route to the internet, 0000/0 through a gateway, the subnet is known as a private subnet. Next, you will create a custom private route table. In the navigation pane, click Route Tables, then Create Route Table to open the dialog box. Click Create Route Table and configure the following. Name, enter Private Route Table. VPC, select Cloud Academy Labs. Click Create Route Table. In the Private Route Table Details page, in the Routes tab, click Edit Routes. Click Add Route and configure the following route settings. Destination, enter 0000/0. Target, select Internet Gateway, then Labs Gateway. important, this is a temporary target value. Later in this lab, you will add a NAT device, gateway or instance, and update the target for the private route table to the NAT device. You are intentionally adding the NAT device last for learning purposes, which will require a minor change to the private route table once the NAT device is created and available. This route will eventually send traffic originating from your private subnet and bound for the public internet to a NAT device. Click Save Changes. Click Subnets from the left navigation pane, then select the private A subnet in the Route Table tab and click Edit Route Table Association. Select Private Route Table from the Route Table ID drop-down menu. Click Save and Summary. In this lab step, you created a private subnet and an associated route table. The route table currently has access to the public internet through the 0000/0 route, but as mentioned before, you will update the target to a NAT device in a later lab step. Let's proceed to the hands-on part and after that reissue the validation check. So now we will switch to Subnet section of the VPC dashboard and create a private subnet in our custom created VPC. So here, let's filter by VPC. Then let's create route table. This name, private route table, and associate it to our custom VPC. Then in the private route table details page, in the routes tab, let's edit routes and add this route, targets internet gateway, labs gateway. So now in the subnet section, private A subnet, let's edit route table association and select this private route table from the route table ID dropdown. From the private A route table, edit and replace this one with our private route table. Save. And let's reissue the validation check. Great, let's proceed to the lab. Step 7, creating a network ACL for a private subnet. Introduction. A network access control list, NACL, is an optional layer of security that acts as a firewall for controlling traffic in and out of a subnet. The network access control list is a numbered list of rules evaluated in order to determine whether traffic is allowed in or out of any associated subnet. NACLs are stateless, which means they cannot tell if a message is in response to a request that started inside the VPC or if it is a request that started from the internet. Hence, a NACL is better suited for private subnets. For public subnets, using security groups is recommended without NACLs. The VPC comes with a modifiable default network ACL, and each subnet must be associated with a network ACL. If you do not explicitly associate a subnet with a network ACL, the subnet is automatically associated with the default network ACL that allows all inbound and outbound traffic, roughly in the neighborhood. In this lab, you will create a network access control list for your private subnet. Instructions. In the left navigation pane, click Network ACLs under Security. Click Create Network ACL. Configure the following network ACL settings. Name, enter private NACL. VPC, select Cloud Academy Labs from the drop-down menu. Click Create Network ACL. Select Private NACL from the Network ACLs list and click the Subnet Associations tab. Click Edit Subnet Associations. Select the checkbox for the private A subnet to associate it with the network ACL. Click Save Changes and Summary in this lab step. You created a network ACL and associated it with the private subnet in your VPC. Let's proceed to the hands-on part. Let's create a network ACL with named private NACL. And let's now verify. Great, let's proceed to the lab step 8, adding rules to a private network ACL. Introduction. In this lab step, you will create inbound and outbound rules for your private network access control list NACL. A NACL is a numbered list of rules that are evaluated in order, starting with the lowest numbered rule to determine whether traffic is allowed in or out of any subnet associated with the network ACL. As a best practice, you will start by creating rules with rule numbers that are multipliers of 100. This can help with organization if you need to insert new rules later on, as there is room within the numbering scheme. Warning: although configuration is not difficult, it is easy to make mistakes or typos. For example, an incorrect digit for a CIDR block can break the lab. Take your time configuring the rules with the instructions below. Instructions. In the left navigation pane, click Network ACLs under Security. Select Private NACL from the list of Network ACLs. Click the Inbound Rules tab below the table and click Edit Inbound Rules. Click Add New Rule and configure the following. Rule number, enter 100. Type select SSH, source enter 10.0.20/24. Allow deny, select allow from the drop-down menu. For the second rule, click Add New Rule and configure the following. Rule number, enter 200. Type select custom TCP rule, port range, enter 1024 up to 65,535. Source enter 0000/0. Allow deny, select allow from the drop-down menu. This will allow return traffic for the outbound rules you will add shortly. The range is specified as 1024 up to 65,535 because these are the available ports and not reserved. This enables resources inside the subnet to receive responses to their outbound traffic. Click Save Changes. Ensure the private NACL is still selected, then click the Inbound Rules tab below the table to verify your inbound rules match the following. Now that you've verified the inbound rules, you will move on to configure the outbound rules. Although the outbound IP addresses can be anything, the ports need to be 80 or 443. In short, operating systems updates needed by instances in your private subnet could come from anywhere 0000/0, but they will be downloaded over port 80 HTTP or 443 HTTPS. You will need to add rules to account for each port. With the private NACL still selected, switch to the Outbound Rules tab and click Edit Outbound Rules. Click Add New Rule and configure the following. Rule number, enter 100. Type, select HTTP from the drop-down menu. Destination, enter 0000/0. Allow deny, select allow from the drop-down menu. For the second outbound rule, click Add New Rule and configure the following. Rule number, enter 200. Type, select HTTPS from the drop-down menu. Destination, enter 0000/0. Allow deny, select allow from the drop-down menu. For the third outbound rule, click Add New Rule and configure the following. Rule number, enter 300. Type select custom TCP from the drop-down menu. Port range, enter 32768 up until 61,000. Destination, enter 10.0.20/24, the CIDR block of your public subnet. Allow deny, select allow from the drop-down menu. Click Save Changes. Ensure the private NACL is still selected, then click the Outbound Rules tab below the table to verify your outbound rules match the following. When you add or remove rules from a network ACL, the changes are automatically applied to the subnets it is associated with. NACLs may take longer to propagate as opposed to security groups, which take effect almost immediately. Note, if troubleshooting efforts are required, sometimes adding an inbound and outbound rule allowing ICMP from anywhere can help while issues are resolved. The ping utility requires ICMP. Summary. In this lab step, you configured the inbound and outbound rules for the private network access control lists. We don't have any validation checks here, so let's proceed to the hands-on part. So for our private NACL, let's edit inbound rules. Let's add new rule. So first one will have rule number 100. That's for SSH. Then new rule with rule number 200 for custom TCP rule with this port range. Then outbound rules. (100) for HTTP. Then 200 for HTTPS. And third rule for custom TCP with this port range. And destination 10.0.20/24, so the CIDR block of our public subnet. Great, let's proceed to step 9. Here all looks as expected, launching an EC2 instance on a private subnet. Introduction. In this lab step, you will launch an instance in a private subnet created earlier. Although the instance does not have database server software installed on it, you can think of it as a database server, which is often shielded from direct access from the internet for security reasons. Once the instance is up and running, you will learn how to SSH into it from your local host via a Bastion host in the public subnet. Instructions. In the AWS Management Console search bar, enter EC2 and click the EC2 result under Services. To see available instances, click Instances in the left-hand menu. Click Launch Instances. In the Name and Tags section, enter Private under Name. In the Application and OS Images section, select the Amazon Linux 2 AMI HVM kernel 510 option under Quick Start. In the Instance Type section, you should not change any options. Simply make sure the default T2 micro is selected. In the Key Pair section, select the provided key pair. Note your key pair may differ from the screenshot. Reminder, the PAM and PPK formatted key pair can be downloaded directly from the Your Lab Data section of the Cloud Academy Lab page at any time. In the Network Settings section, click Edit and configure the following instance details. VPC, select the Cloud Academy Labs VPC. Subnet, select the private A subnet. Auto-assign public IP, make sure this is disabled. Firewall, select Create Security Group. Security Group name, enter SG Private. Description, enter security group for private subnet instances. Accept SSH inbound request from Bastion host only. Type SSH protocol TCP port 22 source type custom. Source SG Bastion. Tip: if you don't recall the name of your Bastion host's security group, leave the source as custom and start typing Bastion. It will find the security group for you. Example SG Bastion. Click Add Security Group Rule, type HTTPS protocol TCP port 443, source type custom, source 10.0.20/24, public VPC CIDR. Note, if you also needed Windows access, you would add another rule, type RDP protocol TCP port 3389, source SG Bastion. Review the summary section and click Launch Instance. A confirmation page will let you know that your instance is launching. Click View All Instances at the bottom of the confirmation page. On the Instances screen, you can view the status of your instance. It will take a short time for your instance to be launched. When you launch an instance, its initial state is pending, but it will transition to running within about 30 seconds. Select the private instance in the Security tab, click the Actionable Security Group link, for example SG Private. Switch to the Inbound Rules tab of the Security group and locate the SSH rule. If the source is not the security group of your Bastion host, click Edit Inbound Rules and enter Bastion for the source. The lookup will find the SG Bastion security group. Make sure it is the source and then click Save. In production, you may want to restrict outbound access to, but for the purposes of this lab, you can leave all traffic to all destinations 0000/0. In an earlier lab step, you launched a Bastion host which used its own security group. However, at the time you configured the security group, there was not a security group for your private instance on the private subnet. Because there is now, you can further tighten down the Bastion host's security group. You'll do that next before using SSH to connect to your Bastion host and private instance. From the VPC dashboard, click Security Groups. Make note of the group ID of the SG private security group. For example, security group with this ID, as shown. Select the SG Bastion security group, switch to the Outbound Rules tab and click Edit Outbound Rules. Now that you have a private security group, you can restrict outbound rules to instances using SG private. Configure the following: type SSH protocol TCP port 22, destination select custom, and then enter the security group ID of SG private. Warning: make sure to delete the existing SG rule and add a new one. Click Save Rules when ready. Next, you will SSH into your Bastion host and enable SSH agent forwarding so you can SSH jump to the private instance in your private subnet. The instructions below assume your local machine is Linux. However, you could use an SSH client such as PuTTY and download a PPK key file from the Cloud Academy lab page credentials section in the left side panel. This instruction is split into two different sections, one for those with local operating systems that are Linux Mac based, and one for those with local operating systems that are Windows based. Complete the instructions below ABC for the one that applies to you, not both. So I have a Windows machine currently available, and I'll sift through these Linux Mac instructions and proceed to read Windows based instruction. Windows instructions. Windows requires an SSH client such as PuTTY, which also includes Pageant. Pageant is an SSH authentication agent that enables you to SSH into a private Linux instance via a Bastion host without copying the SSH keys to the Bastion host. If you do not have PuTTY and Pageant installed on your system, download and install the latest PuTTY MCI Windows installer available at this location. A free and useful SSH utility is called PuTTY. PuTTY supports SSH connections as well as key generation and conversion. The PuTTY package also includes Pageant. Pageant is an SSH authentication agent that enables agent forwarding on Windows. Download the PPK key from the credentials section in the upper left corner of this lab. In the Windows search box, enter Pageant and click the Pageant app result. Alternatively, you can enter Pageant into a command prompt terminal to start Pageant. Note the Pageant runs as a Windows service. It should be displayed in your Windows task tray, but could be hidden. Hence, you may need to show hidden icons. Pageant is displayed as a terminal with a hat on it. Right-click the Pageant icon and select Add Key. Browse to the PPK key file you downloaded earlier and click Open. With the key added to Pageant, it is now available for use with agent forwarding. You can verify the key is added by right-clicking the Pageant icon and selecting View Keys. Open PuTTY and in the host's name or IP address field, enter the username ec2-user followed by @ and the public IP address of the Bastion host. The complete field value resembles ec2-user at 12.13.56.78. Note: your Bastion host public IP can be found in the Details tab of the instance, under Public IPv4 address. Navigate to the Connection SSH Auth section, select the Allow Agent Forwarding and click Open. You do not need to browse to the key, because the key is already available through Pageant, which has the key added and available for forwarding. Wait several seconds for the authentication prompt and click Accept in the PuTTY security alert to acknowledge you trust the host. With agent forwarding enabled, you will be able to connect to the Linux instance running in the private subnet without having to copy of the private key on the Bastion host. To verify the SSH connection was made using agent forwarding, enter echo SSH auth sock variable. If there is no output, the connection was made without using agent forwarding. If that is the case, perform the instructions again to ensure each one is performed correctly. You have now completed the Windows instructions. Proceed to instruction number 16 below. SSH into the private instance running in your private subnet. SSH ec2-user at, then private instance private IP address. Reminder, you can get the private IP address of the instance running in your private subnet from the Running Instances Description tab, then Private IP field. Enter Yes to the Are you sure you want to continue connecting? Yes, No prompt. Congratulations, you successfully created and configured a Bastion host in order to SSH into a private instance on a private subnet. Enter the following command to install operating system updates. Sudo yum update. Although the private instance security group is configured correctly and you should have outbound access to the internet, it is still timed out. The timeout is caused by the private NACL denying inbound HTTP traffic. You will need Network Address Translation (NAT) to allow your private instance outgoing connectivity to the internet, while at the same time blocking inbound traffic from the internet. Once NAT is in place, you should be able to get package updates. Note: for convenience sake, leave the SSH connection to your private instance open. You will return to it in a future lab step. Summary: in this lab step, you launched a basic instance that mimics a database server on a private subnet. It has a private IP address, which in and of itself makes it more secure. You learned how you can still SSH to the private instance by going through a Bastion host. Further, rather than copying private SSH keys to the Bastion host, a security risk, you updated your own authentication chain. That way, you can still SSH from the Bastion host with SSH keys that are not physically copied to the Bastion host. Although SSH access to the private instance worked, you discovered that your private instances still can't access the internet for the purposes of operating system updates, however. See the Securely Connect to Linux Instances Running in a Private Amazon VPC blog for more information. The blog contains great information whether you're connecting from a local Linux or Mac or Windows host. There are no official validation checks in place. In this lab step, let's proceed to do this part hands-on. So we'll search for EC2, then launch a private instance. So let's select for network settings, VPC, our custom created one, private subnet, disabled here auto assign public IP, and let's create security group, the name SG private, and then this description. So instead of the default VPC, let's switch to this one, subnet, our private one, disable, create security group, this name, and description from the instruction. Type SSH TCP 22, source type custom, source SG Bastion. Let's see what we have here available among sources list. There it is, SG Bastion. And let's click add security group rule for then HTTPS, also with custom source type and the source 10.0.20/24 public VPC CIDR. Then let's launch the instance and switch to the instance details, security tab, inbound rules, and verify if inbound and outbound rules are as expected. This looks good. And on the right we can preview code for this operation. Let's launch instance. Then let's switch to the instance details. And 443 and outbound all. This looks as expected at the moment. Okay, now let's make note of the SG private security group ID. So we need SG private ID. That's this. I'll save it in the text editor in the background. And then from the VPC dashboard, click Security Groups, select SG Bastion, switch to the outbound rules, edit outbound rules, and restrict outbound rules to instances using SG private. Okay, let's do that. So from here we'll need SG Bastion security groups and outbound rules. Let's first delete the existing security group rule and then add this one. Let's close out these tabs, or maybe better rearrange them. Here, let's delete this one and add rule for SSH. Custom, and then we'll need SG private group ID. This should be this one. Let's verify from our text editor, ends with E2C. Looks good, and let's save rules. At the moment looks as expected. And now let's proceed to SSH into our Bastion host using Windows specific instructions. So I already downloaded PuTTY. I will download the PPK key. Let's first search for pageant, click on it, and then in the taskbar I see it, and let's add a key. And verify with view keys, then open PuTTY. Looks good. Then open PuTTY, and in out section allow agent forwarding connection SSH out section. And then in session details, for host name, let's type ec2-user at public IP address of the Bastion host. Let's find that. So the Bastion is this one, and its public IPv4 is this one. Let's save that in our text editor. And we'll need the private instances that simulates a database, private IPv4 address. So for the Bastion, it's this one. That should be it. Let's try that out. Open. Let's accept. Great. We are now authenticated as EC2 user on the Bastion. And let's verify the SSH connection was made using agent forwarding. It is. So let's proceed from here to SSH into the private instance using this command, but let's replace this generic name with our specific private IPv4 for the private instance. So let's prepare the command in our text editor. And now we are authenticated as EC2 user on this private instance. We see here different IP address. And let's finally try to update the operating system. And that should fail. We have 1 hour 3 minutes left in this Cloud Lab instance and 3 lab steps left to go. So it says cannot find a valid base URL for the repo. I cannot pull the updates. Could not retrieve mirror list, could not, timed out, okay. So for now as expected. And let's proceed to the lab step 10, launching a network access translation NAT gateway. Introduction. When choosing between a NAT gateway and a NAT instance to handle your network address translations, there are a few key differences to consider. Some examples include maintenance, availability, and performance. A NAT instance is managed by you, which includes software installation, updates, and patching. It also requires additional scripting to manage its availability and failover between instances. Its performance relies heavily on a generic Amazon Machine Image AMI that is configured to perform NAT. A NAT gateway, on the other hand, is managed by AWS, which means you do not need to perform any maintenance. It's highly available with a NAT gateway in each availability zone to improve redundancy. As for performance, the software used by a NAT gateway is optimized for handling NAT traffic. To read more about the differences between a NAT gateway and a NAT instance, refer to the following documentation. Compare NAT gateways and NAT instances. In addition to the differences mentioned above, it's important to note that the Amazon Linux AMI has ended its standard support on December 31st, 2020. Going forward, AWS recommends that you migrate to using NAT gateways or create and maintain your own NAT AMI on Amazon Linux 2. In this lab step, you will create a NAT gateway that will be used by the EC2 instance in your private subnet to access the public internet. You will also revisit the route table associated with the private subnet and update the target entry to point to this gateway. Instructions. In the AWS Management Console search bar, enter VPC and click the VPC result under Services. Click NAT Gateways in the left navigation pane. Click Create NAT Gateway. Begin configuring the following in the NAT Gateway Settings form. Name, enter NAT Gateway. Subnet, select Public A. Connectivity type, ensure Public is selected. The public connectivity type will allow this NAT gateway the ability to access the public internet. Click Associate Elastic IP next to the Elastic IP allocation ID. You will need to attach an Elastic IP address to your NAT gateway. This allows it to be referenced by the route table responsible for routing outbound traffic from instances in the private subnet to the public internet. This allocates an Elastic IP address for the NAT gateway to use. When the NAT gateway is created, this IP address will be attached to the NAT gateway automatically. You will receive the following message at the top of the page. Elastic IP address, this IP as shown, allocated, create, click Create NAT Gateway. You are brought to the details page for your newly created NAT gateway. You will notice the current state will display as pending. Wait for the NAT gateway state to display as available before continuing. This process can take up to 2 minutes. After a brief waiting period, you may need to refresh the page to view the available status. On the left-hand navigation pane, click Route Tables. Select Private Route Table, then scroll down and click on the Routes tab to view the existing routes. You will recall temporarily setting the destination to 0000/0 with the Internet gateway created previously as the target. Click Edit Routes. Locate the 0000/0 destination route and clear the target field by clicking the X. Begin typing NAT, then select NAT Gateway, then NAT Gateway from the drop-down menu that appears. Click Save Changes. And summary, in this lab step, you created a NAT gateway to allow your instances in private subnet access to the public internet. So we have here one official validation check. Let's test it out. We expect it to fail. And then let's proceed to the hands-on part. As expected, let's proceed to the hands-on part. So under VPC dashboard, let's click NAT Gateways and create one with this name. So in the VPC dashboard, NAT Gateways, double check, are we still here in using our, as expected, custom VPC Cloud Academy Labs. Looks good. Let's create NAT Gateway with the name net-gw. Subnet will be public A. Connectivity type public, and let's allocate Elastic IP. Let's create NAT Gateway and wait for the state to display as available. It's currently pending, so let's give it a couple of minutes. Now the state is available. Let's proceed according to the lab instruction. So now we'll navigate to the route tables. In the left-hand navigation pane, select private route table. Click on route and then edit route. Locate the 0000/0 destination, clear the target and then replace it with NAT gateway. Save changes and reissue the validation check. So now in route tables, let's pick this private route table and in the detailed section, routes, then edit routes. So this specific route 0000 should not target internet gateway anymore. Let's click X on this internet gateway ID. Then let's choose NAT gateway. Just created, it's listed and save changes. So with this, let's reissue the validation check. Great. It confirms that NAT gateway has been created. Let's proceed to the step 11, testing access of private subnet instances. Introduction. In a previous lab step, you configured a Bastion host so you could SSH into instances on your private subnet. However, you were unable to access the internet from private instances. A common use case for needing such internet access is operating system package updates. However, the installation failed. In this lab step, now that you have a network address translation device in your VPC, you will test if the operating system updates will work from your private instances. Instructions. If you are not already connected to the private internet via your Bastion host, use an SSH client on your local host to connect to your Bastion host. Hint: refer to a previous lab step for complete instructions. Since you added private keys to the authentication earlier, you should be able to SSH directly from your local host to the Bastion host. Try the following commands on macOS or Linux. So we are using Windows. That's this note below. The code. Note: if you are using Windows, you can use PuTTY to connect to the Bastion host. You will need the PPK key pair and the public IP address of the Bastion host. Remember to use EC2 user as the username. Enter the following command to use the YAM package manager to update the operating system packages on your private instance. Important: there are two important configurations worth mentioning again as to why this command should work in your lab environment. First one, the private NACL has an outbound rule permitting HTTP port 80 or HTTPS port 443 access to anywhere on the internet 0000/0. The security group for the NAT device allows HTTP/HTTPS access from any instance in the private subnet that uses the private instance security group, which permits any destination as well. So the code is sudo yam update-y. And we expect to see some packages updating. No timeouts any longer. We expect it to work. Note: the exact package updates for your system may vary slightly. For example, as the default AWS Linux AMI changes over time. You may also encounter a successful message, no packages marked for update, indicating the instance accessed the public internet, but no updates were required. Summary: thanks to previously performed configurations in several lab steps, you successfully performed an operating system update on an instance in a private subnet. To do so, required access from your private instance, utilizing the route table of a private NACL and a NAT device and its security group. So we already have PuTTY. Still we are connected to the private instance. Just let's reissue the command above to update the system. So when we ran it here, it could not retrieve mirror list. And now let's reissue the sudo yum update -y command, and we have some packages listed, so not as previously with the timeouts. And yes, we get a success message as mentioned, no packages marked for update, but no errors as we saw previously. Great, let's proceed to the last lab step, highlights of securing your VPC. Let's look at the high-level lab environment diagram again and go over some key points to tie this lab together. Time and interest permitting, use the AWS Management Console to look up and/or confirm various settings as you read through this lab step. Realize that different organizations might configure things differently in accord with their security goals and policies. For example, increased or relaxed security on various inbound or outbound rules, etc. The VPC has been configured with two subnets, a public subnet and a private subnet. If a subnet's traffic is routed to an internet gateway, the subnet is known as a public subnet. If a subnet doesn't have a route to the internet gateway, the subnet is known as a private subnet. Instances launched in a private subnet do not have publicly routable internet addresses either. Both subnets have a route table associated with them. Instances on the public subnet route internet traffic through the internet gateway. The private subnet routes internet traffic through the NAT device, gateway, or instance. Each instance launched in either subnet has its own security group with inbound and outbound rules. To guarantee access is locked down to specific ports and protocols. For example, private instances on the private subnet allow any outbound traffic but only allow SSH access from the Bastion host. As another example, although the NAT device is in the public subnet, it cannot be reached from the internet. It has an inbound rule that only grants instances from the private security group, private instances access. Note that you might allow SSH access from your personal IP address or specific administrators as well, or perhaps grant ICMP, ping access during setup and troubleshooting efforts. In addition to security groups, the private subnet also has a network access control list, NACL, as an added measure of security. NACLs allow for inbound and outbound rules specified in priority order. They are set up as implicit allow rules. If none of them are matched, all other traffic is denied. This private subnet NACL in this lab allowed for SSH inbound traffic from the public subnet only. The outbound rules for the private NACL allowed for HTTPS access to anywhere. This was proven to work in the lab by performing operating system updates once the NAT device was in place. The private route table sends the traffic from the instances in the private subnet to the NAT device in the public subnet. The NAT device sends the traffic to the Internet gateway for the VPC. The traffic is attributed to the elastic IP address of the NAT device. So with that, we completed this lab. We have 36 minutes left in this lab instance. Let's sift through the VPC dashboard sections and then submit this lab. So that would be all for this video. Like and subscribe if you enjoyed this one. Until next video. Bye for now.